Hello students, today in physics we are going to study refraction through a lens. If you remember, we have already discussed first part, but I am again going to explain it. Before going to explain refraction, first I would like to recapitulate what is reflection. So I hope you all know when a ray of light incident on a plane surface, it bounces back in the same medium. So this phenomena is known as reflection. You all are aware of it. You have learned in class 9. But now we are going to study refraction through a lens. So first I would like to explain you refraction. As in chapter 4 you have done it, refraction through a plane surface. So what is refraction? Refraction means when a ray of light passes from one transparent medium to another transparent medium, it changes its path. So we can say, suppose this is denser medium, this is rarer medium. It means when a ray of light travels from denser to rarer. So you can see now medium is changed. So how the ray will travel? Its path will change. But how the path will change? According you can see the medium. So when it passes from denser to rarer, it will bend away from the normal. So it will bend away from the normal. So this phenomena is known as refraction. You must have seen that path of the ray of light is changed from its original path. If we say original path means this is original path, but the ray of light bent away from the normal. So this refraction, now we are going to study about the lens. So you all are aware of the lenses also. Lenses play a very important role in our daily life. Lenses are used in making many optical instruments like cameras, microscopes, telescopes and film projector and many more things. See, in class 9, you have studied that the working of a mirror is based on reflection of light rays. You remember all the properties when the ray of light strike on the mirror. So you have drawn the image formation also through the mirror. But in class 10, we are going to study the working of lens is based on the refraction of light rays when they pass through it. So first I would like to explain you what is lens. A lens is a piece of transparent optical material bounded by two refracting surfaces which are usually spherical or one surface being spherical and the other plane. So it is a transparent optical material made up of transparent optical material. As I said, like there are two surfaces. It may be spherical or both the spherical surfaces or maybe one is spherical and other plane. So now we are going to discuss type of lenses. Type of lenses, there are two types of lenses, convex lens, concave lens. But convex lens is also known as converging lens. Concave is known as diverging lens. So now I will explain one by one what is convex lens. See, the convex lens, if you just pick up a lens and you touch, you will find it that in the middle, it will be thicker, this middle part, and thinner at the edge. So how can we define this convex lens? A convex lens is thicker in the middle and thinner at the edge. Or the another way we can define, a convex lens bulges out at the center. Bulges out at the center. So another name of convex lens is converging lens also. Later on we will discuss why we say converging lens. But now convex lens, three types of convex lens. As in the beginning we have discussed what is lens. So this is transparent medium which have either two spherical surface or one plane and others spherical. On the basis of this, we have categorized these three types like this: biconvex. Biconvex means both the surfaces are spherical. Plano-convex means one surface is plane and other is spherical. Concavo-convex, concavo-convex as the literal meaning concavo, one surface is concave and other surface is convex. So these are the three types of convex lens. First, biconvex lens. Actually in use when we read the chapter and just we don't use this by, only we say convex lens, it means that we are going to draw this diagram only, convex lens. Now plano-convex lens, we have already discussed this, so I hope you have understood these three types of convex lens. Same way we can define concave lens. A concave lens also, when you will touch, by feeling this, by touching it, we can say what is concave lens. It seems to, if you touch, you will feel that in the middle it is thinner and at the edge it is thicker. So how can you define a concave lens? A concave lens is thinner in the middle and thicker at the edge. Or another way, a concave lens is bent inward or depressed at the center. Similarly, as we have discussed that convex lens three types, same way concave lens is also three types. First is bioconcave. Bioconcave, second is plano-concave, third is convexo-concave. Now here these two things, concavo-convex and convexo-concave, they both are different in their action. Please make sure the differentiate you should know that concavo-convex and convexo-concave, they both are different in their action. Concavo-convex is converging in nature. Convexo-concave is in diverging in nature. So do not forget how to differentiate it. Now, action of a lens as a set of prism. As I have already told you this, that lens is these two lenses both are the combination of the prism and glass slab. You can see this convex lens, top and bottom. It is very clear that it is a prism and the middle part is glass slab. So if you remember, we have learned this prism, when the ray of light refracts incident on the first surface, and when it refracts, it bends towards the base. So you can see that after refraction, the rays of light is bending towards the base. Similarly, here you can see the ray of light when incident on this surface, you see the base of prism of this part is this. So ray of light will refract towards the base and meet at a point. This point, these two ray of light incidenting, and yes, this ray of light, we are talking about this slab, glass slab. You remember, if the ray of light incident normally without deviation it pass through it, means there is no bending, no change of path. So you can see these A, B, C rays after refraction. These all the rays are meeting at a point. Actually, they are meeting at a point. This means that is why we say this is in convergent action. Means all the three rays after refraction they meet at a point. So convex lens is known as converging lens. Now concave lens. See, when the ray of light incident on this surface, first surface, you look at this prism and base is this. So we have already learned this. After refraction, the ray of light bend towards the base. So base is there. The ray of light is bending towards the base. Same way here, C rays, when the ray of light incident on this surface, and the base is this side. So after refraction, the ray of light is bending away here towards the base. But when we produce this backward, this seems to meet at the point. It means refraction seems to be from focus. So this refraction is diverging. So rays appears to be diverging. From where? Diverging from the focus, from the point. So from the point where the rays seems to be diverged, this point is known as focus also. So here seems to these two rays are diverging. So concave lens is known as diverging lens also. Now next, now we'll discuss technical terms related to the lens. What are the terms which is concerned? We should know. Then only we can discuss the ray diagrams based on the lens. Look at this diagram. This diagram is clearly showing that this is one sphere and this is the another sphere here, and both the sphere are intersecting at point A and B. The same here in this case also. One sphere is this, C1 is the center, C2 is the center, and this is the part. So clearly if you look at this is convex lens and this is concave lens. It means what are the points given here in this diagram? These all the terms you have learned in case of mirror also. But same way we are going to discuss in the lens. This C1 and this C2 is known as the center of curvature. But what is this? How you define the center of curvature? It means center of curvature is the center of the circle of which the lens is part. Means one sphere is this, whose center is C1. Another sphere is this, whose center is C2. And the lens is the part of these two spheres. So how can you define this? Center of curvature. Center of curvature is the center of the sphere of which the lens is the part of it. Now next term, look at this OC1 and OC2. OC1 and OC2 is the radii of curvature. Or if we talk only OC1, if we say, then radius of the curvature. So what is the radius of the curvature? We can say radius of the sphere whose part is the lens. The radius of the curvature, radius of the sphere. This is the radius of the sphere of which the part of this lens. So this OC1 is the radius of curvature. Now next term, this point O. O is denoting optical center. Simply you can define optical center. The geometrical center of the lens, this lens, geometrical center of the lens is known as optical center. This line which passes through the center of curvature, it means simply you can say the line joining the center of curvature is known as the principal axis. The line joining the center of curvature is known as the principal axis, and this is the lens surface. So what are the technical terms related to the lens we have discussed? First, center of curvature. What is center of curvature? Center of the sphere of which the lens is a part. Second point we have discussed, what is the radius of the curvature. Radius of curvature like OC1 or OC2, it is the radius of the sphere of which the lens is a part. Principal axis, line joining the center of curvature. Optical center, it is the geometrical center of the lens. So student, the same term is related to the concave lens also. The same way we can define for the concave lens also. Now this radius of curvature will be equal only when the both the sphere are of the same radius. Now the another important point, the related
Go.
now some another important point. First focal point we are discussing simultaneous. As you can see the diagram, this lens source for the first focal point. First focal point, it is a point on the principal axis of a convex lens such that a rays is starting from it. See, the rays is starting from it after refraction travel parallel to the principal axis. A ray starting from where? From the first focal point. After refraction, it travels parallel to the principal axis. So this F1 is known as the first focal point. And the distance between optical center and first focal point is known as the focal length. So OF1 is the focal length and it is denoted by small f1. A line passes through the first focal. A line passes through the first focal and perpendicular to the principal axis. See, this line is passes through the first focal point and look at this principal axis. So how are they? They are perpendicular to each other. So this line is known as the first focal plane. This is known as the first focal plane. This is for convex lens, first focal plane. Now we are going to talk about the concave lens. See, it is the point on the principal axis of a concave lens. This F1 is the point, first focal point on the principal axis of a concave lens such that the rays of light appearing to meet at it. Actually it is not meeting but appearing to meet at it. After refraction, you just see, after refraction the ray of light is parallel to the principal axis. This point is known as first focal point. And the distance between the optical center, same way, distance between the optical center and first focal point is focal length and denoted by F1, OF1. How did you find the first focal plane? As same way in the convex lens we have discussed, a line passes through the first focal point and perpendicular to the principal axis is called first focal plane. Similarly, we can discuss the second focal point. Second focal point, look at this. This is convex lens, a principal axis, optical center. When a ray of light incident parallel, after refraction, look at this diagram. After refraction, they meet at a point. They converge at a point. This point is known as the second focal point, F2. Same way, the distance between the optical center and second focal point is known as second focal length, F2. And how did you find second focal plane? Same way, a line passes through the second focus and perpendicular to the principal axis is known as second focal plane. Now in case of concave lens is the diverging lens. So when a ray of light incident parallel, it's after refraction, it seems to be refract from the F2, diverge from the this point. This point means second focal point is known as second focal. This point is known as second focal. And distance between O and F2 optical center and f2. Optical center and second focal point is known as second focal length, and it is denoted by f2. We have already discussed this. So student, I hope you have understood, and once again I'll recapitulate. I have discussed with you, first thing, what is lens. So how many types of lens? Two types, convex lens and concave lens. So each convex and concave are three types according to the surfaces, like bioconvex, plano-convex, concavo-convex, same way concave lens. Afterward, we have discussed technical terms related to the lens. Technical terms are related to the lens means we have discussed about center of curvature, radius of curvature, optical center and principal axis. Then we have discussed first focal point and second focal point, and what is focal length. So now please you go through the content. You must read chapter 5a and learn all the important points. This whatever I have sent, you please write this note in your register and learn it. Do the back exercises of 5a along with the diagram. And yes, one more important thing. So wherever you need to draw the diagram should be drawn only with the pencil scale. No pen. Please, no pen. You will be not rewarded any marks in the board exam if you use pen. And the second important thing, if you have not marked arrow. Even your diagram is perfect. This diagram is perfect, and without arrow, no marks will be rewarded as per ICSE rules. So please make sure use only and only pencil, and do not forget to put these all the arrows. Thank you and God bless you.